Good morning. Today's lesson is on the derivatives of transcendental functions. So basically, we will focus on the following derivatives. The derivatives of a to the x, which is a to the x. So this is the derivative of a natural exponential function. Then the derivatives of a to the x, which is a to the x ln of a. That's the derivative of an exponential function. And of course, the derivatives of the six trigonometric functions. Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. Derivative of tangent x is secant square x. And the derivative of cotangent x is negative cosecant x. The derivative of secant x is secant tangent x. And the derivative of cosecant is negative cosecant cotangent x. Let me give you some examples for the derivatives of e to the x. So let's find the derivatives of f of x equals e to the x plus x squared. So this one is an example of a sum rule. That means you will have to find the derivative of each term. Derivative of e to the x is e to the x, and the derivative of x squared is 2x. So that our final answer is f prime of x is equal to e to the x plus 2x. Next, we have f of x equals 4e to the x plus 3x to the fifth minus x cubed. So again, this one illustrates sum and difference rule, where you will have to find the derivative of each term. So you'll have 4e to the x for the first term. Then you'll have 3, which is the constant multiple, multiplied with the derivative of x to the fifth, which is 5x to the fourth, minus the derivative of x cubed, which is 3x squared. This will simplify to 4e to the x plus, again, this is 15 x to the fourth minus 3x squared. For the third example, let's have y equals e to the x times the quantity x squared plus 2x. So this is an example of a product rule where you have e to the x to be your first function, and then x cubed plus 2x to be the second function. So basically, this is your f and this is your g. So for y prime, that will be e to the x times the quantity of the derivative of the second function. So the first function is copied. Derivative of the second function is 3x squared plus 2, plus the second function is copied times the derivative of the first function, which is e to the x. So here you will have to distribute e to the x for each of the term inside each parenthesis. So you'll have 3x squared e to the x plus 2e to the x plus x cubed e to the x plus 2x e to the x. Of course, you will have to rearrange this in such a way the first term has the highest power. So you got y prime to be x cubed e to the x plus 3x squared 3x squared e to the x plus 2x e to the x plus 2 e to the x. For the second set of examples, we have a to the x, where its derivative is a to the x ln of a. So let's find the derivative of f of x equals 9 of x, 9 raised to x. 9 serves as the base, which is our a. So that would mean if you find f prime, this would be 9 to the x ln of 9. Second example is f of x equals 4e to the x plus 12 raised to x. So this again is a sum rule. For the first term is 4e to the x for its derivative. And then 12 raised to x is 12 raised to x ln of 12. And then for the third set, we have the examples for the trigonometric functions. Y equals 3 sine x plus 5 cosine x. So this one is again is a sum rule where each term represents a constant multiple. Here we have 3 and 5. So the derivative of sine is cosine. The derivative of cosine is negative sine. You just have to replace them. So you have 3 cosine x plus 5 times negative sine x. Again, this will simplify to 3 cosine x minus 5 sine x. For the second example, you got y equals tangent x plus 3 cosecant x. Derivative of tangent is secant square. Derivative of cosecant is negative cosecant cotangent. So that our answer will be secant square x plus 3 times the negative of cosecant cotangent x, which will reduce to secant square x minus 3 cosecant x cotangent x. For the last example, we have f of theta equals 3 theta squared cosine theta. So instead of x, what you're seeing here is theta. So that means our variable is theta. So 3 theta square is one factor multiplied to the next factor or the second factor, which is cosine theta. So basically, this again is a product rule. So the first factor is 3 theta square times the derivative of the second factor, which is negative sine theta, plus cosine theta, which is the second factor. Derivative of 3 theta square is 6 theta. So this will simplify to 3 theta square negative times sine theta plus 6 theta is actually multiplied to the entire function of cosine theta. So you can rewrite this as 6 theta cosine theta. So we do not multiply 6 theta and theta of cosine because 6 theta is multiplied to the entire function. Okay? I guess we have had enough examples for you to be able to check yourself and find out if you could answer the following given. So I'll give you some time to answer this, and afterwards, we will discuss the answers.